Hi everyone, welcome to the third lecture webinar in the series on survey design on CPHS. Thanks for coming. It's amazing that so many of you have chosen to voluntarily donate your Friday evenings to us 3 weeks in a row. We are absolutely floored that people find what we're doing interesting and useful. So we're very glad that we can help people understand how we run the survey. And this is the last in the series on survey design. Thanks again, everyone, for coming. And we hope to be doing much more of these soon. I'll start the presentation at 5. As usual, I have with me Mahesh Vyas. Mahesh is the chief architect of the Consumer Pyramids Household Survey. The two of us will be answering your questions on weights, and we'll try and make this as informative a session as we can. Like I said, this is the third in a set of 3. The first webinar was on survey design broadly and sample size. We talked you through how we get to this magic number of 174,405 households that we survey across the country. Webinar number 2 was about attrition, response rates, changes in sample across time. We took you through everything that's happened, all the learnings that we've had from the 1st of January 2014 until the end of 2019 in being able to conduct what is by no means an easy survey across the country, in rural, urban India, in all kinds of states, all kinds of terrains, all kinds of natural conditions. This is the last of the 3. This is on weights. We've now hit 6:05, so I will start the presentation. As always, if you have any questions, please ask your questions in the Q&A box. While I'm speaking, Mahesh is actively looking through your questions and will try to answer as many of them as he can over text. Some questions might require some discussion, in which case we will take those questions once I'm done. I hope to wrap up in about 55 minutes. Mahesh, just a quick check. Are you able to see my screen?
Yes.
Okay, great. Rock and roll. All right. So everyone, thanks for coming. This is the third in an exciting series of talks on CPHS survey design. Today's talk is on weights. And it's perhaps of the 3, the most complex, the most technical, and also the longest. So it's a challenge for us to communicate everything that we're doing in weights to you. And we're going to try to do the best that we can. You'll almost surely have questions as I take you through the materials. So if you do have questions, just a reminder again, the Q&A box is open. Please type in your questions and we'll do the best that we can in answering them either in real time or after my talk is done. So I'm going to dive right in. And I'm going to dive in with a motivation that for those of you who come to previous talks, you're familiar with this picture. These are the homogeneous regions of Karnataka. If at this point you're saying, oh, what is a homogeneous region? We've covered this in great detail in lectures 1 and 2. I'll do a quick recap in just a couple of slides. For now, all you need to know is that a homogeneous region is just a collection of neighboring districts that makes sense to be studied together and to be surveyed together. Now, Karnataka is broken up into these 5 homogeneous regions. And I'm going to put some numbers onto this map to help motivate what it is that we try to do with weights. So 5 homogeneous regions, HR 1, 2, 3, 4, 5. Let's assume, for the sake of argument, that each of these HRs has the exact same population, 100 people. Okay? And then we run a survey in each of these HRs where we survey just one person from each HR. It's a really mini CPHS. And we ask only one question to these people. We just ask, are you employed? Are you not employed? And so there's one person per HR. 4 of them say that they're employed. One of them says that they're not employed, the one in HR 1. Okay. So first, let's talk about the sample, just these 5 people in the survey. How many people are unemployed in the sample? That's really easy, right? You can count this. 1 out of 5 people are unemployed, or 20%. Now, we can also ask questions about the population. We can say, how many people are there in Karnataka? That has nothing to do with the survey. That's just a feature of Karnataka. And so we sum up the populations and we say, okay, there are 500 people in Karnataka. Great. Then we can ask the question, how many of them are unemployed? And so what we could do is we could look at this survey, which takes one person from each of those 5 regions and finds that 1 out of those 5 people are unemployed. And we could extrapolate out from the survey to the entire state. And we can say, if 1 out of 5 people in the survey are unemployed, then probably 1 out of 5 people in the state are unemployed, which means that 100 people are probably unemployed. Okay, great. So far, so good. Now let's complicate matters a little bit. So first complication, look at HR1's population. It's now risen. HR1 now has 200 people, while all the other HRs still have 100 people. So let's ask the question about the sample first. Everything else stays the same. We still run the same survey, 5 people, 1 from each HR, and they still have the same answer. 1 of them is unemployed, the other 4 are not employed. Okay, so we ask the question again in the sample, how many people are unemployed? The answer stays the same, 1 in 5, right? So 20%. Then we ask the first question that we asked last time about the population. How many people are there in Karnataka? Now that number's gone up. Okay, so it was 500 people. Now we've bumped up the population of HR1. So now it's 600 people. And then we ask the next question, which is how many of these 600 people are unemployed? Now there's one way you could do it. One way you could do it is you could say, well, 1 out of 5 people in my survey are unemployed. So I'm going to go ahead and say that 1 out of 5 times 600 people are also unemployed. But you could do better, right? Because you know that that population is not evenly spread across the 5 HRs. In fact, HR1 has 200 people. All the other HRs have just 100 people, right? So we could take advantage of the fact that we have one observation from HR1 and one observation from each of the other HRs to get at a better guess, right? So we have one observation from HR1. We know the population of HR1 is 200 people, and that one sample from the survey is unemployed. So we can assign all of HR1 to be unemployed because we only draw one person out of that huge population of 200 people. They say they're unemployed. We don't have any other information. So we assign HR1 to be all unemployed. So 200 people unemployed and remaining 400 people still employed. Okay. And again, there's nothing fancy here, no math, no algebra. This makes sense intuitively. We can do this. Now, let's complicate matters even further. Instead of surveying one person from each of the HRs, for some reason, I'm now surveying 2 people from the first HR. And when I survey those 2 people, one of them says that she's employed. The other one says she's not employed. Everything else is the same. Population stays the same. The people being surveyed in other parts of Karnataka stay the same. So we can ask the same question in sample. How many people are unemployed? Now this changes because it used to be 1 in 5. Now it's 1 in 6. So about 16.67% of the sample are unemployed. Then we can ask the same question about population. How many people are there in Karnataka? Well, I've not changed the population, right? So it's still 600 people in Karnataka. But now in HR1, I have 200 people in the HR in total, and I'm also surveying 2 people from that population, of which one of them is employed and the other one is not employed. So within HR1, the unemployment rate, it used to be 100 when I was just serving one person. Now it's fallen to 50% of HR1's population, right? And so the number of people that we would guess to be unemployed in Karnataka is now down to 100. Okay, so now one last addition to this example. Let's bump up the population of HR1 again. Let's make it 300 people. Ask the same set of questions. How many people are unemployed? In sample, it's the same. Population has changed, nothing else has changed, right? So 1 out of 6, 16.67%. How many people in Karnataka as a whole? That's gone up by 100, so it's now 700 people. And how many of them would we say, of this 700, would we say are unemployed? Let's pause, since I've been speaking so fast, and go through what I just said. And we'll start from HR5 and work our way up to HR1. In HR5, the population is 100. I have one observation from HR5, and that observation is employed. So I'm probably going to guess that all 100 are employed. Okay. Then HR4, same story as HR5. One sample unit says he's employed or she's employed. So I'm going to guess all of HR4 is employed. Same for HR3, same for HR2. So already 400 people 1, 2, 3, 4, 400 people we know are employed. Now, HR1 has a population of 300 people. And one of the people from my survey, I have two people in my survey, 2 out of 300 are surveyed. One of them says they're employed, the other one says they're not employed. So a good guess would be that 150 people in HR1 are not employed, half, and another 150 are employed. Okay, that's how we would say that 150 people in Karnataka are unemployed. If you just did 1/6 times 700, you'll get a lower rate. Okay, everything we just talked about, all this math, arithmetic, whatever you want to call it, was actually fairly intuitive. We could talk about it in words. We could illustrate through figures, visually. So what did we do really? Right? What is the math that we did? It was this math, what you see on the bottom of your screen. And we're adding up the contribution of each of the people in our survey, and each person contributes differently. And what matters to their contribution, those contributors, those are called weights. And what matters to those contributions? Two things. One, the total population that each of those individuals from our survey represents. And two, how many people represent that population, the number of sample units. That's all a weight is. It's just that ratio. Okay. So now let's abstract away from this example and think about what a weight is. A weight is just that. It's the ratio of the total population that a given sample represents divided by the number of sample units. Okay. Now we can complicate things. We can have weights that change over time, because it could be that the underlying population changes over time. It could be that the number of people that I survey changes over time. It could be that both of those change over time. We could have weights for different geographies. I could have one weight if I'm just trying to do HRs. I could have another weight if I'm trying to do states. I could have a third weight if I want to do all India estimation, etc., etc., etc. Then we could have weights for different groups. As most of you know, Consumer Pyramids Household Survey is a survey of households. So we could have weights for household level estimation. If we want to say so many households have an income, a household income of more than 100,000 rupees, or we could do it for individuals, or we could do it for individuals above the age of 15, because those are the people that are likely to participate in the labor force, right? And each of those groups could have different weights. Okay. So today's talk is to talk about how are all of these different potential weights created in CPHS and what weights actually exist for researchers to use. Okay, so now for those of you who are new, who haven't attended lectures 1 and 2, I'm going to try to recap each of them in one slide each. I also recommend that you go and watch the entire talk, because each talk was an hour long with 30 minutes of questions. But here's a quick recap. Lecture 1 was about two things: stratification and sampling. Stratification is very simple. It's how do you divide the country to be able to run a survey. And so here's how we do it. We divide states into something called homogeneous regions. Homogeneous regions are just collections of neighboring districts that primarily share the same agroclimatic conditions and also share similar rates of female literacy and urbanization. Okay. Then we break those homogeneous regions down into urban and rural parts of every homogeneous region. And then we break the urban part into 4 kinds of urban strata: small towns, medium towns, large towns, and very large towns. So in total, that gives you 5 strata for every homogeneous region: a rural strata, a small town strata, a medium town strata, a large town strata, and a very large town strata. Okay, these are theoretical strata. Okay, so if we do this exercise and we map out all of India, we will get 550 theoretical strata, 110 HRs. That's an agglomeration of 640 districts up into 110 HRs. Each HR has 5 strata. That gives us 550 theoretical strata. Not all of them exist. Some districts don't have a rural section, for example. So 631 out of 640 districts in India don't have, it's the other way around. 9 out of the 640 districts in India don't have a rural component. Okay, so some strata don't exist. So if we take out those non-existent strata, 550 theoretical strata give us 412 real strata. Of those real strata, CPHS doesn't have the reach in all of them. In fact, only 389 of them are accessible by CPHS, And of those 389, 379 are currently being surveyed. The difference between those that are surveyed and those that are accessible, which are 10 strata, are strata that we plan to go into the future. And we also hope at some point, perhaps, to be able to go into the strata that are currently inaccessible. But of these 379 strata that we actually do survey, that accounts for 98.5% of India's population. Okay. Now, let's talk about sampling now that I've given you a lightning recap of stratification. Sampling is simple. I have primary sampling units. That's how I choose from where I choose my households. Okay. What are those? I select villages from every homogeneous region by simple random sampling. So I randomly select villages. I do the same thing for towns. I randomly select towns. I do one additional thing for towns. When we randomly select towns, we make sure that we select at least one very large, at least one large, at least one medium, at least one small town. Okay. This is called stratifying on town size. Now, once we have those towns, from each of those towns, a town is divided into wards. Wards are divided into census blocks. We pick 21 census blocks at a minimum from each of those towns, again at random. And as the town gets larger, we pick more and more census blocks from a town. Those are our primary sampling units. That's villages picked at random and eventually census enumeration blocks picked at random. And there's multiple levels of randomization in the way in which we pick those blocks. We start by randomly selecting towns. Then within each town that we randomly select blocks. Okay, so we do this exercise. And then once we have the villages, once we have the blocks, from each village, each block, we select 16 households at random using systematic random sampling. And exactly how we do that was a big part of that first talk. Now, when we do this entire process all across the country, we work our way up. We hit 3,965 villages and 322 towns. And we sample from each of those villages, each of those towns. And that's what gives us our total sample size in CPHS, which is 174,405 households. That's a recap of survey design and sampling. Now, I want to move to lecture 2 and give you a recap on response rates and attrition. We can't go through all of it. Here's a figure of overall response rates in CPHS. The point of this figure is to show you that while there were ups and downs, the band is narrow. The lowest point was 82% response rate. The highest point was 87% response rate. That's just a 5 percentage point gap, and it's a very, very high response rate. The key takeaways are that our sample has definitely grown over time. That's a good thing. We're trying to grow our sample. It's grown by 4.5% from 2014 when we started to 2019 today. We have a response rate of almost 85% on average. The one wave survival rate is almost 90%. So this is in the panel. How long does a household survive? The 2-year survival rate is almost 50%, and it's getting better over time. So for newer waves, that's closer to 60%. Almost 25,000 households across the country have participated in every single wave of the survey. We've done 22 waves, and almost 25,000 households had participated in every single wave up until the 19th wave. We're going to put together the documentation for waves 20, 21, 22 very soon. Survival rates are improving. This is the most important point. We have gotten better at surveying. We know how to do surveying better. We've learned on the job over the last 6 to 7 years. And so now our survival rates are improving every wave on wave, every year on year. All right. So that was the key takeaway from our second webinar, which is on sample attrition, changes to the sample, etc. Okay. Now, finally, everything that I've told you is already documented on our website. So if you go to consumerpyramidsdx.cmi.com, and if you click on how we do it, you'll get a list of documentation. All of this documentation has been written by CMIE and is freely available to anybody. You don't need to be a subscriber. You just need to have a username and password for CMIE, which is free. And once you have that username and password, you can download all of our documentation. We encourage all of you to please read our documentation. Please ask us questions, because this is how we improve the quality of the survey as well as the quality of the documentation. If the documentation is too dense, then you can go to our YouTube channel, youtube.com/CMIE India. All of our lectures, including the ones on survey design, are available online. You can also see every single CPHS research seminar that we've done since October. We've done 6 of them already. Okay, with that recap out of the way, let's get back to what today's talk is all about, which is how are weights created, what weights exist and how can they be used. So here's the agenda for today's talk. Remember, the weight, the formula on the right-hand side, is just the ratio of capital N over small n. So we need to understand, how do we find small n? How do we find capital N? Then how do we compute the weight? And then finally, how do we adjust for non-response? Non-response is what we talked about last time. Okay, so I'm going to start with the easiest part, which is how do we estimate small n? Okay, remember, small n is just the number of units that were actually surveyed. So that should give you a hint about how we estimate small n. Small n is very easy to estimate. No estimation necessary. We know n precisely. N is just the sample size. And small n, we can break it down because of the meticulous planning that CMIE does, both in terms of time as well as in space. We know for every strata, for every month, every week, what is the sample size going to be. So small n is completely and perfectly known thanks to all the hard work that we've already done in survey design. That's great. We can move on. Done. Lecture over. Thanks everyone for coming. But not quite. Despite the fact that estimating small n is very easy, estimating capital N is actually a very demanding but also incredibly interesting task. So what is capital again? Capital N is the population that we're trying to study, right? And so how do we know what is the entire population of India? Well, we have the census. And the census has been working since 1901, and it gives us perfectly reliable estimates of India's population across time. That's wonderful. That's great. But the census happens only once every 10 years. And so actually those bars that I showed you, this is the actual spacing if we count every single year in the x-axis. And now you might start to see the problem. And the problem is the last census was in 2001 and CPHS began in 2014. So in 2014, there was no estimate of India's population other than the 2011 census estimate. The next one will be hopefully this year in 2021, right? But in 2014, we didn't know 2021's population. We still don't because census hasn't been done yet. Luckily, there are projections. So there's a group called the Technical Group on Population Projections, and they put out a report called Population Projections for India and States 2001 to 2026. Now, that report uses Census 2001 data. And that report was published in May of 2006. But that was before CPHS. And so those projections can help us in estimating capital N because those projections go out all the way to 2026, right? Well, not quite, because remember our ask. Our ask is actually very demanding. We don't just want capital N as the population of India as a whole. We want to slice up that capital N by all kinds of different groups, all kinds of different geographies, potentially all kinds of different time horizons, right? So what do we really want? So let's focus on that I subscript first. I could be any of these three groups. We could want to create estimates of the total population of households, the total population of individuals, or the total population of individuals above the age of 15. Now let's go to G. Our aim, our incredibly ambitious aim, was to estimate the population in each and every town and each and every village in India. Not just those in CPHS, and I'll tell you why in a minute, but each town and each village in India. So there are 7,933 census towns in India. There are 640,953 villages in India. And we said, is there a way in which we can estimate the population of each town and each village across India? Now, why would we want to do this? Why would we ever take on something this ambitious? Because if you can do it right, then you can build up the population of each district, because a district is just a collection of all the towns and villages. And then you can build on top of that the population of the state, because then the state is just a collection of all districts. And then finally, you can aggregate up to the population of India, which is just the collection of all states and union territories, right? And why? Why would we want to do this? Are we just suckers for punishment? No. The most important reason is we wanted to do something that was future-proof. As I showed you in the last lecture, CPHS has grown over time. The aggregate change is 4.5% increase between 2014 and 2019. We're constantly adding new towns, new villages. Sometimes we have to remove towns and add towns. Sometimes we have to remove villages and add villages for a variety of reasons, which I described in the previous webinar. And so we have to have estimates for all towns and all villages, because at any point a new town could be added, and then all of a sudden I need a population estimate for that town. Or a new village could be added, and I might need a population estimate for that village. That's reason number one. Reason number two is it's the only way in which you can have a completely consistent grounds up way of estimating total population in the country. There's another way in which we could do this, is we could come up with one way to estimate population of towns and villages, another way to estimate population of districts, a third way to estimate population of states, a fourth way to estimate the population of India. But then the problem with that is over time, each of those things is going to do different things. It's much better if we can say, and we know this is true by construction, the population of districts is the sum of the population of towns and villages. So if we can accurately estimate the town and village population, we can build our way up, right? That consistency is very important. And finally, it's just nice when things add up. You like it. There's a feeling of great pride in showing that everything lines up, right? And that's the ideal way, the best way to do it. That was what we thought. That was our ambitious, very, very ambitious ask. Now, we watered down that ambition, but only very slightly. What we did is we said, okay, maybe individual villages is a bit too much. Maybe we can't do that. Because there are 640,953 villages. And there's just too many of them. But more than that, they have very short lives, villages. All kinds of things can happen. A migration can wipe a village out. A flood or a landslide or some natural event can wipe a village out. It could potentially even create a new village. Villages, especially these days, get swallowed by cities as cities are growing. Villages can themselves grow and then merge into a new village. So all of these complications exist. And so then we decided, okay, we'll take a step back. We won't be so ambitious. We'll still want to estimate the population of every single town. But for villages, let's estimate the entire rural population of every district, district by district. Now, if you remember, I said India had 640 districts as of census 2011. Of those 640, only 631 have a rural portion. Okay, so that means that we have to estimate the population of 7,933 towns across India and the rural portion of 631 districts across India. It's still a very, very ambitious ask. This is the G. Okay, so we've now understood the I that we want to do and the G that we want to do. G stands for geography, by the way. Okay, now the time dimension. In principle, we could create population estimates at a daily level, a weekly level, a monthly level, at a wavely level. For those of you that aren't very familiar with Consumer Pyramids Household Survey, the survey is conducted in waves. Every wave is 4 months long. So there are 3 waves in a year. Or we could also make estimations at the yearly level. Now, you might say, CMI, why are you doing this? Why do you want to create a population estimate that increases every single day? And the reason is, we might want to create estimates from the survey that actually can be done every single day. So already today, CPHS executes somewhere in the order of 1,000 to 1,200 households a day. And we are constantly growing the survey. It's very possible that one day there will be a survey that's large enough that we have a sample size that can create daily estimates of unemployment, of asset ownership, of anything in CPHS. And we are thinking with that timeline in mind. So we want to make sure that when we design our weighting system, in principle, we can create estimates at the daily level, the weekly level, the monthly level, the wavely level, the yearly level, whatever we want. Okay, so that's the ambitiousness of the ask along the time dimension. So let's summarize all these very, very ambitious asks together. Along the I dimension, the group dimension, we could do it for individuals, we could do it for households, we could do it for individuals above the age of 15. Along the T dimension, we could do it everywhere from daily all the way to yearly. Along the geographic dimension, we want to do it for every single town in India and every single rural part of each district in India. This is an incredibly ambitious ask. Now, can we use the projections of the technical group on population projections to service this ask? Unfortunately, the answer is no. Reason number one, along the time dimension, these projections do not allow us to do daily. Okay. Along the geographic dimension, there are no estimates below the state rural urban level. We want to do estimates for every town and every district's rural level. All right. That's not given to us in the projections made by the technical group. And finally, all of this is actually based on Census 2001. This report came out in 2006. So even though there was a new census in 2011, there wasn't a new report by the technical group on population projections using 2011 census data until November of 2019. And we started the survey in 2014. So sitting in 2014, there was nothing other than this. And so given that we had a very ambitious ask, the only available option for us is to make our own projections. Now, this is a very, very difficult thing. How are we going to make our own projections of population across India? So let's first talk about methodology. What does the technical group do? Right? The technical group uses something called the component methodology. What they do is they make projections for a cohort, assuming constant fertility, constant mortality, and constant migration rates. They get this information from an absolutely amazing thing called the sample registration system, or the SRS. Now, unfortunately, we don't have full access to the SRS. And secondly, the technical group itself said that this methodology, the component methodology, is not appropriate for making projections for populations of less than 10 million. And we want to make populations, again, let me remind you, for every single town, every rural part of every district. And as we know from last lecture, of those 7,933 census towns, everybody knows which is the largest in population. That's Mumbai. Which is the smallest in population is Valia in Gujarat. And Valia, as Mahesh told us last time, has a population of 5, right? So for such small populations, it doesn't, the technical group itself says that the component methodology may not be the right way to do this. Okay, so what do we do instead? The CMIE approach is to create decadal CAGRs. CAGRs are cumulative annual growth rates. Okay, it's very simple. We make projections assuming continuity of trends in population growth rates between 2001 census, that's 2001 census, and 2011 census. So between a decade, we compute cumulative annual growth rates for every single town and every single rural part of each district. That's easier said than done, okay? Because doing this requires a comprehensive mapping of towns and districts between Census 2001 and Census 2011. And such a mapping does not easily exist, okay? So what did we do? Well, we started off with the ask. The ask is there are 640 districts in the 2011 census. We have to map each of them to districts in 2001 census. Now, 537 of them, easy. We got a direct match. 103 of them were unmatched. So what do we do? Well, we found this, something called Table A2 in the census documents, talks about the decadal variation in population all the way since 1901. And we posted a picture of this on our Twitter handle, and we asked people to tell us what's so interesting about this particular table. Okay, the answer is this. This district, Krishnagiri, is in Tamil Nadu. And Krishnagiri was bifurcated from another district and created only in 2004. Despite that, there are population estimates all the way from 1901. So census has some way of taking newly created districts and finding out what their population would have been had those district boundaries existed even in the past. And now we have to somehow reverse engineer this. Okay, so how do we reverse engineer it? Well, we use that table A2. And here's what we do. We find all the towns and villages in 2001 that match towns and villages in 2011. Those are directly matched, 537, no problem. Some new districts have towns and villages that didn't exist in 2001. And so what do? we locate the parent town or the parent village from which a new town or village was carved out using something called the MDDS location code directory in the census. And then we map each parent town in census 2001 and each parent village in census 2001 to its new town or village. And using that information, we sum up the population of all the parent towns and parent villages to create what the population of this newly formed district would be. And then we check whether the sum that we created matches the sum that's in table A2 for 2001. Right? So when census shows you that in 2001, Krishnagiri's population was so much, when we do our own math, do we get the exact same number as them? For 63 of those 103 unmatched districts, we get an exact match. Exact match. Okay, great. But still, another 40 are not matched. So what do we do for those 40? Well, for those 40 districts, we simply assign the 2001 populations in proportion to the population of the parent districts that these new districts were carved out of. Okay, so if one district was carved out of 3 districts, and those 3 districts had different populations, in proportion to those populations, we carve out their contributions as far as the new district is concerned. And we also map over the rural-urban distribution, the household size distribution, and the proportion of population above 15 in that same proportion as the parent districts have. For 5 districts, after doing this, we still had to do a manual correction. Okay, this was because sometimes when a new district is created, it doesn't actually mirror the characteristics of its parent districts. Here's one example. The Ganderbal district was bifurcated from Srinagar. But Ganderbal was made to be primarily rural, while Srinagar was primarily urban. So it wouldn't have made sense to assign Ganderbal what would have effectively been a bunch of urban characteristics. Okay, so 5 districts, we did a hand check and we said, well, this doesn't make sense. And so we need to make this make more sense. Okay, and so this process of those 40 districts, 35 of them, we just did this proportionate mapping. For 5 of them, we did the proportionate mapping and then some hand corrections so that it actually made sense. Okay, and great, that's districts done. 640 districts, of which some of them required exact match using the A2 table, and about another 40 of them required this proportional mapping exercise. Now towns are much harder because there's 8,000 towns. So at this point, someone should be typing in a question furiously saying, oh, hold on. I thought you said there were 7,933 towns. And if you're asking this question, then you're really paying attention. You're right. There were 7,933 towns, and then there were 134 outgrowths. Okay, so in total, there are 8,067 census towns. Now, for these towns, you have to do the same exercise. We have to find their parent towns in 2001 to compute the decade-on-decade growth rates. 4,840 of them, direct match. Great. But 3,227 of them, there's no match. So what do we do? First, we find another table. In this case, it's table A4 of Appendix 1. And this table, if you look at those first few columns which are highlighted, is all about new towns. New towns were created in Census 2011, which weren't in existence before. We've talked about this before. In both webinar 1 and 2, I've talked about the proliferation of census towns. This is that proliferation. So luckily for each of those new towns, this table in census documents gives us the 2001 population. Okay, great. What about the remaining 500? So of those 544, we do firstly the same thing that we did for districts. We do the MDDS match. That's for 391 of those towns. We find the parent towns in 2001, and then we use the parent towns and villages from 2001 to sum up populations and check against the table. In this case, it's no longer table A2, it's table A4, to make sure that our summing up of 2001 towns and villages reaches the same population as table A4 says. This is the same idea as what we did for districts. Okay, we did that successfully with 391 of them, got exact matches. There was still 163 remaining. Now what do we do about those 163? Okay, we found out another 57 of those 163 were declassified. So they were in 2001, census declassified them. They were no longer towns. So they were towns in 1991, then they got declassified in 2001, then they got reclassified into being a town in 2011. Okay, so all of those towns, luckily, were also in table A4. And so we were able to get the 2001 rate as well as the 2011 rate. Great. We still have 106 left. Of that 106, here's what we did. 81 of them we hand matched. No problem. 25 of them, we tried everything. We were not able to come up with a match. So for those 25, first, let me tell you, it accounts for very little. It accounts for 0.1% of just India's urban population, not even total population. India's urban population, 0.1% in 2011. That's those 25. So for those 25, since we couldn't do anything, what we finally did is we took the district's overall urban and cumulative annual growth rate, and we applied it to those 25 towns. Okay, great. And so that's how we mapped towns. So in lightning speed, I've taken you through how we mapped districts from census 2001 to towns, to districts in census 2011, as well as towns in census 2001 to towns in census 2011. This is a mammoth task, absolutely mammoth task that we pulled off. Now, after having pulled off this great big mammoth task, the work is not yet done, because we now have 25,692 separate CAGRs, CAGRs to compute. Now, you at this point, again, you should be scratching your head and saying, Kaushik, how? What is this number? I don't understand. I was able to follow you. You said 7,933 towns. You said 631 rural districts. How are we suddenly at 25,000 now? Okay, and so the answer is as follows. It's a product of two things. The left-hand side is the 793 towns plus the 631 rural parts of districts. And now for each of those 8,564 areas, we need three different kinds of CAGRs. Cumulative annual growth rates. We need an individual CAGR, we need a household CAGR, we need an individual over than 15 CAGR. Because why? Because we want to create estimates for individuals, we want to create estimates for households, and we want to create estimates for working age populations, which are individuals older than 15. That's how you get 25,692 CAGRs that we have to separately compute. Again, 15,232 of those were accepted, no problem. Another additional 10,460 required more work. Now, why did they require work? I'll take you through each of the things that we did to tweak those CAGRs so that they actually made sense. First thing that we did is that for about 7,933 of the CAGRs, CAGRs, the age distribution in official documents is not available at the town level. And so what we did is we tweaked it and we gave the urban average to all the towns for the towns in a given district. Okay, this is only for, it's not for all individuals, it's only for the population of individuals above a certain age threshold, because that information is given even in census only at the district level and no further. Okay, then we perform a very important exercise for 2,000, roughly 2,000 of these CAGRs called censoring. What we do is we nudge growth rates towards the mean. Now, I'll tell you why we do this. Imagine that there's a town that's really, really, really low on the growth rates over time, or a town that's really high on the growth rates. And what do I mean by really low or really high? Let's take the town strata that we have, very large, medium, and small, and we bin up growth rates into quintiles. Quintiles are 5. So 5 equally spaced bins of growth rates. Now, the growth rates in the first bin are the towns that are growing at a very slow speed. The growth rates in the very last bin, the 5th bin, are towns that are growing at a very high speed. Towns that are growing at a very high speed, it's unlikely that they'll be able to sustain that very, very high growth into the next decade. Similarly, towns that are growing at a very slow speed, something will change. They'll start growing faster over the next decade. So we expect some amount of reversion towards the mean. So what do we do is, if you are a town in the middle of those 5 quintiles, in the middle 3 of those 5 quintiles, we accept your growth rate as it is. If you are a town that has a growth rate in the 1st quintile or the 5th quintile, very low or very high growth, in that case, we censor it. What we say is, no matter what your actual CAGR was computed, we are going to give you the second quintile CAGR if you're a town in the first quintile. Similarly, if you're in the fifth quintile, you get the fourth quintile CAGR. Okay, so if you can visualize, imagine 5 boxes next to each other. The first box and the fifth box, they disappear. And all the entities in that first and fifth box, they just get their neighboring boxes' values. Okay, and that helps us to kind of trim the distribution of CAGRs so that it's more meaningful. Now, for the very large towns, the large towns and medium towns, we don't have enough of them. Okay, there are only 50 very large towns in India, only 110 large towns, and only 375 medium towns in our sample. And so we do this at an all India quintile level. Okay, sorry, not in our sample, in India as a whole. For the 7,000 small towns, we use state-specific quintiles because there's so many small towns that we can actually do this at the state level. So state by state, we create those quintile bins, and then we censor out the first and the fifth quintiles. We also do this for the rural districts, and we do this again at the state-specific level. Okay, so for very large and medium towns, the censoring for everybody, whether you're a very large, medium, small, rural district, we do censoring. What's the censoring idea? If you're growing very slowly or very fast, we push you towards the mean. If you're a very large town or a medium town, that pushing towards the mean is done using all India data. If you're a small town or if you're a rural district, then we have more points, and so we are able to do that binning, that censoring, that compression of the distribution at the state level. Okay, so that's what we did as a tweak for 2027 of the CAGRs. Then for 500 of them, we had a slight rounding error. Now, remember, what did we do? We computed the urban population of every single town using the CAGR method, town by town. And I've told you that there's huge variation in town size. You've got census towns with population of 5, like Valia. So you can imagine that if we do this exercise and we sum everything up, sometimes we may not actually get, by summing up all the urban populations that we've computed, we may not get the total district urban population, right? We may be off by a little bit. And so if we're off by a little bit, that difference, how much ever we're off by, we attribute that to the rural population of those districts. So think of it as just a rounding error, and that rounding error happens for about 50 of the CAGRs, 500 of the CAGRs. And so that correction is also applied to 500 cases. Okay, and that's it. So now I've taken you through how we estimate capital N. First, I told you why we have to estimate it ourselves, because we have an ask that's incredibly demanding on data, and that data didn't publicly exist. And so we had to compute those growth rates ourselves. And to do that, we had to compute the growth rate of every town in India separately and every rural portion of every district in India separately. And then using that information, we had to compute CAGRs. We computed over 25,000 CAGRs. And then we had to tweak those CAGRs to make sure that the CAGRs weren't off by too much. And we've taken you now through that entire process. Having taken you through that process, let me try and show you what the end result is. So the bars that you currently see, those are actual census estimates, the 2001 census population and the 2011 census population. Now I'm going to show you our projections using our method. That's the 2011 projection and the 2021 projection. I would say that's pretty good. Okay, and we can also look at that technical group. Remember, there was a technical group that came up with its own projections. And there was one technical group in 2006 that came up with projections until 2026, but it used census 2001 data. It's very dated. We just found out, because it happened so recently, that in November of 2019, a second report was finally put out. And that report uses census 2011 data to create projections from 2011 out to 2036. So how do we do CMIE in 2021 compared to the most up-to-date projections that exist from the technical group and population projections? That's the 2019 projections. Here's the answer. Again, we do remarkably well. We do pretty good. We consistently overestimate, And we know this, okay? And that's the work that we have to do for the future. We consistently overestimate the population because when you do the CAGR style thing, you don't take into account the fact that there is a secular downward trend in growth rates, mostly driven by a fall in fertility. And so this is not to say that the work is done. We know that this is an issue, and now the next work for us is to take all of this into account and make even better projections. We can take new administrative data into account. There's SRS data that's now available. These new 2019 projections are available. Census 2021 will happen. That will give us a wealth of data. Also, CPHS has grown. CPHS, the survey, is stable and is now a source of data itself on population projections. We can potentially use CPHS data to create our own estimates of fertility, mortality, migration, and feed that in to our own population estimation. And so this is future work, and this is an admission that we see a systematic, slight overestimation, and we're working to try and address that in the future. Okay, so that's been a whirlwind of a ride. We're at 6:55. I hope most of you are still with me. And we've now at least managed to understand how to estimate small n, very easy, that's just the sample size, and capital N, which is population, but not just all India population, all kinds of populations. Okay, great. Now that we've got small n and capital N down, all we need to do is compute weights. But first, let me just summarize, right? So the summary is as follows. We require to have daily projections at the level of each census town, the rural part of each district, of all individuals, all households, all individuals above the age of 15. Official projections don't provide this. We make our own projections using decadal CAGR, using census data. To do this, we map all 2011 census districts to 2001 census districts. We map all census 2011 towns, 8,067 of them, to the census 2001 towns. After the mapping is done, we compute CAGRs for each projection of interest. That's 25,692 CAGRs. We aggregate that up to the population of India. And what do we find? CMI's population projections are very, very close to official estimates where they exist, like 2011, or official projections where they exist, like the 2021 projection. Very close. Okay, great. And finally, yes, they will get better over time. Now let's move to weights. This should be fairly straightforward, right? We've computed capital N, we've computed small n, so we're done. We just take the ratio of the two. I wish it were that simple. Unfortunately, it's going to take me a few minutes to get through this part, but it's actually quite simple. So if you have followed us through how we estimate population, you've got the gist of it. Now it's just making sure that we take ratios correctly. Okay, so quick recap. Weights have the same subscripts as capital N. There's an I subscript, a G subscript, and a T subscript. I is different groups, different individuals. That's households, individuals above 15. Now, G, the geography, is slightly different. For population projection, this was the breakdown of our geography. India is broken down into states, states are broken down into districts, districts are broken down into either towns or the rural portion. In weights, we do things slightly differently. India is broken down into states, states are broken down into homogeneous regions. Homogeneous regions are broken down into 5 strata: very large, medium, small, and rural. Right? This is driven by our survey design and sampling. So we provide weights for our survey design. Okay, so we don't provide weights for districts. We don't provide weights for individual towns or rural portions. We provide weights for homogeneous regions, and within homogeneous regions for the 5 strata: very large, medium, small, and rural towns. Okay, so CPDX weights are constructed in accordance to our survey design and sampling framework, not in accordance to the administrative boundaries used in India. Now, let me help you make sense of all of this, because this can get a little confusing. So weights are provided, and I'm saying this again, weights are provided at the lowest level at which strata exist in the survey. That's within a homogeneous region. And what's a homogeneous region? A homogeneous region is just a collection of districts. So within that collection of districts, for each stratum, whether it's the rural stratum, the small town stratum, the medium town stratum, the large town stratum, or the very large town stratum, we provide weights for each of those levels. That means that you can create an estimate. The finest estimate you can create geographically is at the level of an individual stratum for an individual HR. So you could take coastal Karnataka homogeneous region and create an estimate just for the small towns in coastal Karnataka. Okay, coastal Karnataka homogeneous region consists, I think, of 3 districts, uh, uh, Uttar Kannada, Dakshin Kannada, and Udupi. You can also sum up all the strata in a homogeneous region. That's the very large, medium, small, and rural. And that will give you the estimate of an entire HR, of an entire homogeneous region. If you wanted weights appropriately for the state level, that's easy. You simply sum up all the strata weights for each homogeneous region, and then you sum that up across all homogeneous regions. Right? So it's just you keep summing up. You sum up all the strata for an HR that give you the HR. If you do that for each HR, then you just sum up the HR that will give you the state. If you want to do India, you just sum up all the states. This is the beauty of the system that we've designed. The reason that we wanted this consistency in population projections is it's a simple construction of sums geometrically that will give you the national level weight if you need it. And the beauty of that is that you can create different verticals. So if you wanted just the very large towns of India and you wanted to create an estimate for that, you can do that. You simply sum up all the weights for very large towns across each HR, summing up to every state, summing up to all of India. Any kind of summing up that you do is consistent because of the methodology that we use in creating weights as well as in doing population projections. That's the amazing beauty of this system. It takes some time to absorb this beauty. And so if you have questions, please do ask us and we'll try to answer as many of them as we can. Now, there's one catch to this entire thing. Okay, all of this summing up is consistent. It's perfect. So can you just sum up all the weights if you want to create an all India estimate? We would still advise you not to do that and instead to use another weight that you will see in the micro data called the India estimate for a given stratum. And that's because of non-surveyed strata. Now, remember I told you there are 550 theoretical strata. We don't survey all of them. We survey 479 strata, if I remember correctly. The number is again on the next slide. So as an example, Andaman and Nicobar Islands are not surveyed. The far northeast, Mizoram, Manipur, Nagaland, and Arunachal Pradesh are not surveyed, right? And so you may still, as a researcher, like to somehow take them into account when you create an all India estimate. Because when you create an all India estimate, you don't want to say, well, my estimate is all India, except for the parts of India that CPHS does not survey, right? You'd like to make a statement about all of India. So is there a way to do that? And we say yes. What you can do is the thought experiment you want to ask is there some HR that CPHS does survey that could stand as a proxy for these regions that CPHS doesn't survey? Is it similar on enough characteristics that if I just adjust the weights, that one HR could actually stand in for all of the other regions that I don't survey? Okay, can we map them somehow to an HR that is surveyed? The answer is yes, we can. There is an HR in West Bengal called Darjeeling Kuch Bihar, and Darjeeling Kuch Bihar is the stratum that's most comparable to these strata that we don't survey, which is Arunachal Pradesh, Nagaland, Manipur, Mizoram, and Andaman Nicobar Islands. Okay, so can we somehow get Darjeeling and Kuch Bihar to stand in for these non-surveyed regions? That's the question. The answer is yes. What we can do is as follows. We can pretend that each observation inside Darjeeling Kuch Bihar actually represents not just Darjeeling Kuch Bihar, but also Arunachal Pradesh, Nagaland, Manipur, Mizoram, and Andaman Nicobar Islands. And that is, remember, what is the weight? The weight is capital N over small n. Small n doesn't change. It's the same number of surveyed units because there are no survey units in any of these states, in any of these non-surveyed regions. But those non-surveyed regions have a non-zero population. And CMI has projections of all populations because we make projections for every single town and every single district, regardless of whether our survey operations actually take place there, right? So we can adjust the weight by changing capital N while keeping small n constant. So the vanilla weight for Darjeeling Kuch Bihar would just be the thing on top, which is the estimated population, projected population for Darjeeling Kuch Bihar divided by the number of sample units in Darjeeling Kuch Bihar. If you wanted, you could create an even more powerful weight, which is where Darjeeling Kuch Bihar stands in for itself, but also these regions that are not surveyed. So think about this intuitively. What does that mean? It means that now every single observation in Darjeeling Kuch Bihar stands for Darjeeling Kuch Bihar itself, but also a much larger population. Okay, so in principle, for a total population, we have fewer sample units, but those sample units can now at least partially speak to a much larger population, which otherwise you couldn't speak to. Now, this exercise, do you see how we've constructed this new weight? The new weight is the population of Darjeeling Kuch Bihar, added to that the population, the estimated population of all these non-surveyed regions. We can do the same exercise for every single non-surveyed strata. We find the most comparable surveyed strata and we load up the population, the estimated population of that non-surveyed stratum onto the surveyed stratum to create a new weight. Okay, that's it. I know it sounds complicated, but it's actually very intuitive, very straightforward. It's simple arithmetic. Now, go back to the slide that I showed you in lecture 1. Of the 550 strata we have, 138 don't exist, 23 are inaccessible, 10 are scheduled, and 379 of them are already surveyed. This thing that we're proposing that you can do is for these 33 strata. 33 strata are not currently surveyed. They exist in India, but they're not currently surveyed by our survey machinery. So for these 33 strata alone, we've created another set of weights that you can use if you want to account for these 33 strata. And before you say, oh my God, CMIE, what a mess you've made. I don't understand this. I hate this. This is wrong. Just remember, we're not forcing you to use them. You can always use the regular weights if you want. We've done all this additional work to help you account for just 1.5% of India's population. But the way we've done it is transparent and it's scientific and it's sensible. And so our encouragement to you, what we would advise you to do is use it, because this will allow you to create even better, in our opinion, all India estimates and state level estimates. Okay. Now, one final caveat is that sometimes one non-surveyed stratum may need to be mapped to a different surveyed stratum for the state level estimate and a different surveyed stratum for the all India level estimate. Because what are we trying to do? We're trying to say, okay, this stratum is not being surveyed. What is the most comparable stratum in our survey that we can use to create an estimate for this stratum? And when we're creating a state level estimate, what makes something comparable can be different from when we're creating an all India level estimate. So in a few cases, very rare cases, you will have that one non-surveyed stratum gets mapped to a different stratum for the state level estimation and a different stratum for the all India level estimation. Okay, so the best fit may differ for the state and for the nation depending on which estimate you're trying to create. For example, the Moradabad Bareilly median town stratum, not all of Moradabad Bareilly. Moradabad Bareilly is an HR. Of that HR, just the medium town stratum is not surveyed currently. And so it's mapped to the Meerut Bulandshahr medium town stratum for all India estimation. And it's mapped to the Bagpat Bijnor large town stratum for state level estimation. It happens very, very rarely, but it happens in the data. And we wanted to make sure that we tell you about it. Now, the exact same logic that I've given you for non-surveyed stratum can be extended naturally to episodic stratum. Episodic stratum are stratum that are surveyed in the survey, but sometimes for something or the other, in a particular wave or maybe a wave or two, a particular stratum doesn't get surveyed. These are examples. So for example, many of you that came to last week's talk will recall that there were all kinds of problems in Kutch in wave 1 in Gujarat. And so wave 1 was a problem for Kutch and Jamnagar. Then we had all kinds of problems in Aurangabad because we discovered that there were two towns that are actually twin towns of each other. And so we had too much of a sample for those towns. Then we dropped one of the towns and then we added some new towns, right? So in that confusion, a particular small town stratum for a given wave here or there doesn't get surveyed. Sometimes it's because of COVID, right? So for example, in wave 20, which was a COVID wave, the medium town stratum for coastal Karnataka and the small town stratum for Kashmir didn't get surveyed. And so even though they are temporarily non-surveyed, we can extend the same logic to allow a mapping to a surveyed stratum so that you can still make state level and all India level estimates that take this into account. Okay, that's it. So I know that's a lot of it, but that tells you fully what our weights are capable of and what they allow you to do at a geographical scale. So we're adding on 2 layers of complexity, non-surveyed strata and episodic strata. They can apply across the board anywhere in India. And so weights for any stratum then come in 3 flavors. There's a vanilla weight, which is just for that, only for that stratum if you want to create an estimate. There's a state level weight, which allows you to appropriately weight the stratum if you're trying to create a state level estimate. Then there's an India level weight, which allows you to weight any stratum if you're trying to create an all India estimate. Okay. Even if a stratum doesn't contribute to a state or to India differently from just itself, we still give you all 3 weights so that you don't have to pick and choose and you don't find suddenly that one weight is not applicable here. We complete all the weights for you so you can just pick up any set of weights and do your work. Okay, so we do all the hard work and we give you all the weights so you can choose which of these things to do. So as non-surveyed data become surveyed, they will eventually get their own weights. And in the meantime, what we recommend is you use the state level weight and the country level weight, not the vanilla weight, if you want to make a state level estimation or a country level estimation. You don't have to worry. If a given stratum doesn't contribute differently to state or country, then there's no change between the regular vanilla weight. If it does, the change is accounted for, so you can simply use the state level weights or the country level weights as you need to use for your research. Okay, vanilla weights are best used only for individual stratum. Okay, great. So that takes care of the geographical complication with weights. Now, 7:10, not as much time for Q&A as before, but I'm going to now finally, the last part, I'm going to get through the time dimension of weights. The time dimension of weights is quite straightforward. We want weights, like I told you, because we are very, very ambitious. We want weights that allow you to do daily estimation, weekly estimation, monthly estimation, wavely estimation, and yearly estimation. Now, what is the appropriate capital N to use? Because we are creating daily projections, you just use the capital N on the date at which whatever time period you're interested in ends. So if it's the day, it's that day. If it's the week, it's the last day of that week. If it's the month, it's the last day of that month, etc., etc., etc. Capital N is not a problem. Okay, small n is just how many units are actually surveyed in a given point in time. Now, at the moment, only month level weights and wave level weights are in CPDX. Okay, that's all that are there in CPDX. But we are able to create all of these weights, all the way from daily to yearly. Now, with the month weights, there's one added complication, and this is because people ask this question so often that we felt we would add this complication to also clear up this doubt that people often have. People often say, oh, CMIE, CPHS, you tell us you have monthly data on income and consumption expenditure, but why is it delayed? Why does it take 4 months? This is why. So suppose you want the household income, you want to estimate household income for January 2021. Remember, the survey takes 4 months to complete, which means the survey for any wave, even for January, when I start in Jan 21, ends on the 31st of May, right? And so in Feb, in March, in April, and in May, there are households being surveyed. I meet households only once during the wave. And so if we want to know their Jan 21 income, I can't ask them in Jan because Jan isn't finished. So I can, the earliest I can start asking them is in February. But only a quarter of the households are actually met in February. Another quarter of households are only met in March. And that's the time when I can ask them for their Jan income. And another quarter are met only in April. And that's when I can ask them about their Jan income. Because the last time I met the April households was actually in October. So I never asked them their Jan income, right? Because I meet them once only every 4 months. The same is true for May. So getting household income for the entire panel, for the entire sample, even for Jan 21, requires starting in Feb 21 and ending in May 21. Okay, so the appropriate weight, and this is called the series weight, takes into account that we have to collect sample over 4 months. Okay, so capital N is actually the full sample, the sample from Feb until May. And small n is also the full sample. It's the sample, capital N is the population ending in May, and small n is the sample between Feb and May. Okay, there's another way you could do it. In principle, you could just take the quarter of observations in February and try to compute an estimate for January using just that quarter of observations. Okay, we call that a monthly slot estimate or a monthly slot weight. That's different from what you see on the bottom, which is called a monthly series weight. The difference with the monthly slot weight is and the monthly slot estimate is it's made using only a quarter of the total sample strength. We do this. CMI does this. That's how we produce monthly employment statistics in our other services like Economic Outlook. But this is not what's done in CPDX. CPDX is meant more for researchers who want high volume data, right? And so you want data for the entire sample. And so in CPDX, we give you the weight on the bottom, which is called the monthly series estimate. So with that caveat, you have the monthly series estimate and the wave level estimate available in CPDX currently. Okay. So that's it with weights. Great. 7:15, almost done. I told you this was the longest talk, the most complicated talk, the most technical talk. And so even though I'm speaking very fast, it is going to take me some time. Quick summary of weights. Just like population projections, weights come for different, there are different weights for different projections that you're interested in. If you want to project to all individuals, all households, all individuals above the age of 15, there are different weights that you as a researcher can use. Projections for these groups can also be made for different locations. If you want to make just an individual stratum estimate, there's a weight for you. If you want to make estimates at the all India level, there's a weight for you. If you want to make estimates at the all India level, including areas that we don't survey, there's a weight for you. If you want to make an estimate anywhere in between, you can create that weight with all the raw material we've given you. Okay, projections can also be made at the wave level for most indicators, and for income and consumption, they can be made at the monthly level. All of these weights are given to you in CPDX. Okay, so lots and lots of weights. That's the message here. Despite that, people will say, well, what about those 3 other weights? When are you giving us those? We'll get there. Now that you've understood small n, capital N weights, the last thing is to adjust for non-response. Non-response is what I spoke about last week. Okay, so non-response. Let's talk about this. We're almost done. Don't worry. Just 2 or 3 slides left, and then we'll move to Q&A. So the weight is just capital N over small n. Capital N, total population. Small n, number of sample units. Now, CPHS sample frame may mean that 2 people are surveyed from a particular village. Okay? But we go into the field. Well, not 2 people. Let's be realistic. A village has a sample size of 16. So 16 households are supposed to be surveyed in a village. But we go into the field, and then for some reason, only 14 of them actually get surveyed. And so we don't want to be dividing capital N by 16 because only 14 actually got surveyed. We'd like to divide them by 14, right? And so what we'd like to do is we'd like to do capital N over N prime, the number of actually surveyed units, not the number of sample units in the sample frame. There's a very easy way we can do it. That same formula I showed you is equivalent to this formula. Capital N over small n times small n over n prime, where n prime is the actual number of survey units and small n is the number of survey units as dictated by the sample frame. Okay. The reason this formula exists is then I can rewrite capital N over small n to just be the weight. That is your weight, capital N over small n. So if you simply multiply your weight by this new ratio, which is the ratio of the actual survey units in the sample frame divided by the number of survey units that actually responded to the survey, that will give you the appropriate amount of estimation that each unit should contribute towards a larger estimation that you have in mind. This ratio is called the non-response factor. And the beauty is that in CPDX, we give you weights along with non-response factors. And so what you need to do as a researcher is you need to take the weight, you need to multiply it by the non-response factor. That's the appropriate amount of scaling that every observation deserves. The weight accounts for decisions taken during survey design and for the underlying population. The non-response factor accounts for unexpected things that happen in the field. There is non-response, right? Our average non-response, our average response rate was 85% for the first 19 waves. So you have to account for the fact that 15% of your sample doesn't respond. The NRF, the non-response factor, allows you to do that. Okay, so I'm going to summarize now non-response factors. Non-response in the field requires correction to the weights as the effective small n changes, right? So CPHS solves for this with the provision of non-response factors, NRFs. All you have to do as a researcher is you take a weight. For every weight, you literally control F, the indicator name of the weight. You will find a corresponding non-response factor. Multiply the 2 of them. Use that as the scaling factor for any observation, and then you will get the right estimation that you're interested in. Okay. Of course, this was a theoretical talk about small n, capital N, weights, and non-response factors. Many of you will have applied questions. Now that I've understood all this, Kaushik, how do I actually get anything done? We're working on that. So we'll come back to you with a next talk in some time, in potentially more time than you expect, on how you can actually apply those weights. But the building block to applying those weights is understanding those weights. And the purpose of this talk is to help you understand those weights. So why did we show you all this? It's not to flex our muscles. Okay. One, we are thinking about research applications. We are not just running a survey and spitting the survey out there. We understand that the survey feeds into research. And the fact that we think about research applications helps us in doing more than just giving you raw data. Okay. Given the survey design that we have, given the way in which we conduct the survey, we understand that weights are required for various different projections that researchers might have in mind. And we do the work of providing those weights, different kinds of weights for different projections. And our weights are not static. Our weights take into account the fact that India is growing in variable ways over time. And so our weights are updated every single day so that you have the most appropriate weight as far as we can construct. Our weights let you make projections that account for the fact that our survey still doesn't yet touch 1.95% of India's population, 1.5% of India's population. It's very small, and we're getting there. We're just not there yet, right? There is a huge, huge machinery that goes into the production of these weights. And there's three reasons why we show them to you. The first is to tell you, we're exposing this machinery to you to demonstrate that each step has been executed with a great degree of thought and also with a great degree of experience. CMI runs Consumer Pyramids Household Survey, but we also run Economic Outlook, which makes all India level estimates as well as regional estimates for a variety of things. States of India, which provides estimates at the state level. Industry Outlook, that's providing estimates economically at industry levels. CapEx, which is telling you about capacity expansion and infrastructure projects across the country. Prowess, which is telling you about firms across the country, etc., etc., etc. We already understand the difficulties in, for example, the fact that geographic boundaries do not stay constant across time. They change a lot. But because we aren't just running a household survey, we're also in the business of telling the world about India's economy across all kinds of different scales, that we have the experience to do this hard work of mapping towns, districts, creating the machinery in place that creates the population projections that are necessary, not just for CPHS, but for many other services in CMIE, and the weights that are necessary in CPHS, but also, for example, in Economic Outlook. For those of you that subscribe to Economic Outlook, we provide monthly employment and labor force statistics there. Those rely on these same weights, the same procedure that I'm describing to you here. Of course, the last reason, which goes without saying, which has been the reason where we've done this entire set of talks, is to keep reaffirming to the world our commitment to transparency. There's a commitment that we have at CMIA to ensure that you know everything about how the household survey is run. So much that then you are telling us, bus, enough. This is too much, Kaushik. You overdid it on transparency, right? We'll be happy to be at that level, right? We want you to be telling us, this is enough. You've really told us everything about the survey. We don't need to know anymore. And we want to demonstrate not just that we're telling you everything about the survey, but when you read what we've written, when you hear what we have to say, you walk away feeling like, okay, I understand what CMI is doing. I understand the reasons that they're doing what they're doing. Hopefully, they understand the trade-offs that they are making, and they are comfortable with the set of trade-offs that they make. And so at least I understand what's going on. Right? That's the real aim and ambition behind this set of talks. It's also to help you with your research. So it's now past 7:20. So that's it. Thank you, everybody, not just for coming to this talk, but for coming to the other two talks. If you haven't seen them, they're available on YouTube. I'm going to stop sharing my screen now, and I'm going to take a look at the Q&A. Ah, wow. A completely empty Q&A. Hi, Mahesh. What's been happening while I've been rambling on? Mahesh, you're on mute.
Sorry. There have been a few questions and I have addressed them, but those questions are obviously very simple ones. Renuka Sane had a question which was to do with application. How do you use these weights when you're trying to combine information from multiple waves, for example? And I think we owe all of them a more detailed answer than I have given them right now on application of these weights in making estimations. So we will write a separate note on that subject and come back to you. But that will take several weeks to do. But in the meanwhile, I encourage all of you to write to us and ask us your questions, and we'll try and answer them in a piecemeal way as well. And the best part of those questions will be it will also guide us in the manner in which we construct this next note, which is how do you use the weights in different conditions. I have come across a few questions earlier from some other users. Renuka's was one today, but we'll be happy to take this forward. And I understand that there cannot be too many questions given that this is a rather heavy subject, number one. Number two is just telling us how we did it. That's about it. There's a question now, Kaushik, if you can look at it now.
Oh, there's a new question. Oh, no, Mahesh. I had sent out a chat to everybody with my email address so that in case they want to write to us, they can. Is there anything that you would like to add, Mahesh? You are the author of this note and you are the chief architect of CPHS. Is there anything that I've missed that this audience should know about weighting, about population projections, about this entire mammoth machinery that we have at CMI?
I think the most important thing for us is that we'd like to explain to all users is that we face a lot of challenges in putting together this entire machinery, where we wanted to have a very large sample and we wanted to have good representation of the various towns, which meant that we were not going to do proportionate sampling, population proportionate sampling. So which means that weights would necessarily play a very big role in the use of this data. Now, when we say that the weights would play a very big role, then the question was what weights to use, given that we wanted to do fast frequency, geographically granular, so on and so forth. So while we have approached the problem in a certain way, we also admit that there is more work to do. We see that we are systematically slightly above overestimating in our estimations of population over a 10-year period. You did not say this, but we may also tell everyone that the technical group is systematically underestimating the projections. So lesser than our overestimation, but nevertheless, they have over the last 3 exercises systematically underestimated population. So you know whether you do component method projections or you do compounded annual rate of growth. Either which way, you will get something slightly wrong. But I think what we have done is very exciting and very useful, is we have cracked it at the fast frequency level and at the granular level. That's what I think is important. I think we should, in the foreseeable future, also give more weights for more faster frequency data to enable people to do more work with CPHS. So lots of work to do. We have already begun the work of making better projections, assuming that the 2021 census will not happen in time. So that's the biggest thing that we were waiting for the 2021 census to happen so that we can make our corrections. But now we can't wait for it because we know it is delayed. And what do we do if it is delayed? So most likely we are going to make corrections to our population projections earlier than the 2021 results come out. Nowadays, we also need to fear that although the census may happen, even if it happens a little late, it's quite possible that the results will take longer to come out, as seems to be the case nowadays with government data. So all in all, we're getting ready for a scenario where 2021 census does not happen in time, the data does not come in time. We cannot live with an ever increasing larger estimations by us. So we're going to make the estimations corrections a little faster. The team, principally my colleague Nitika Malhotra, is working on this already, and we should have something to tell our audiences very soon on that.
That's great, Mahesh. Thank you so much. I see Mithika is in the audience. Mithika, thank you for coming, and thanks for the amazing work that you and the team put into creating these weights, these population projections. Mahesh, as you say, with the prospect of Census 2021 getting delayed, it becomes all the more urgent for us to be able to continue to make population projections that we can rely on, and to, where possible, supplement the statistical system to collect data that's useful in answering questions. Thank you for those comments at the end. I don't have much else to say. We're almost out of time. I'd like to quickly thank the audience. I can see many of them have come to all three of our talks. So thank you so much to the audience for coming to not 1.5 hours, but actually, this shows how bad at math I am, 4.5 hours of us talking about the survey design. It's great that there is this level of interest. And I'm delighted that we're able to cater to the interest thanks to the excellent documentation that we've now produced. Mahesh, thanks for producing this documentation. Thanks for coming to these events, answering questions, giving all of us your thoughts as well as directions about where CPHS is going next. I think that's all I have to say. If you have any final words or thoughts to sum up this 3-lecture series on survey design, the floor is all yours.
No, I think a big thank you to all those people who attended all these talks by Kaushik. We will keep feeding you more. Thank you everyone very much.
Great. Thanks everyone. Goodbye.